Good morning from the Rooster Inn Observatory. The big sunspot that we were looking at yesterday is still here. It is big, and there are a few more sunspots around. These are the two that have been traveling for the past several days, working their way from east to west. These are new as of yesterday, and this is the big one. This is early in the morning. We're expecting some clouds to move in, so I did not want to take a chance of missing this completely. Speak of clouds moving in. So there is the sunspot. It was still there, it is still there. We're gonna hang in for a few minutes to see what. This is a smaller cloud moving through. But there's obviously quite a bit of turbulence on the edge of the sun because of the humidity in the air and because it's so low just up off the horizon. I'm not going to attempt to capture anything right now. It is futile. But we're going to keep an eye on. We're going to keep an eye on the sun, on that sunspot, and see what it does. Even the most rudimentary mathematics suggests that this sunspot is bigger than the Earth. The diameter of the Sun is 865,000 miles. The diameter of Earth is 8,000 miles. So 1 in 1,000. And yeah, that's a lot more than 1 in 1,000. So we're looking at a sunspot bigger than Earth. Well, I'm gonna grab a ruler and do some measuring. All right, quick calculation, quick measurement shows that this sunspot is about 10 times the size of the Earth. The atmosphere is starting to calm down a bit. So I'm going to go back in and see if we can look at that sunspot. I'm going to try to do some hydrogen alpha filter tuning and then sharpening the focus. See if it gives us anything. Also, the clouds are contributing their filtering. Let's look at the edge of the sun, see if there are any solar flares taking place right now. No. Okay. Unusually quiet. Just the usual tiny things around the edge. Yeah, a few tiny ones here and there, but nothing of consequence. So the only excitement in the sun today is that big sunspot, which is about 10 times the size of the Earth, diameter-wise. So I'm going to leave you with that, and wish you all a good day. Yeah, this is the big sunspot. I did some crude, rudimentary measuring to put it in context, and it is about 10 times the diameter of the Earth. Sun has a diameter of 865,000 miles. Earth is about 8,000 miles. So Earth is about 1% of the Sun, diameter-wise. And this is certainly a lot more than 1% of the diameter of the Sun. The other two sunspots that we have been tracking all week are still making their journey westwards. These two up here. Let me zoom in onto them quickly. Here they are. We started the week right around here, and they've been moving slowly and steadily. As the sun rotates around its own axis once every 25 to 26 days, so we expect these to continue their journey west or left over the next probably another week or so before they disappear. But this big sunspot appeared for the first time yesterday. Had not been there, it came out of nowhere. And the same is true with the activity at around 5 o'clock. This all appeared yesterday for the first time. Let me take another look at this one. Here, this activity here. So we have these two new areas to keep an eye on over the next few days. Let me take one more quick journey to the edges and see if we want to see any solar flares or prominences one more time. The way I do that is I change exposure from what is right now 1/2000th of a second all the way to 1/60th of a second. This is 1/2000th, which is where we are now, and then all the way down to 1/60th of a second. And that shows the edges. Burns out the disk, overexposes the disk, so we can see the minor details near the edge. Not much. There are a couple tiny ones. There are a few on the left side of the sun, on the west side. Nothing around the poles, which used to be active. Really nothing there. Just a few on the left side. And they're not much to speak of. Okay, going back to the big sunspot and the clouds, of course. That is the big sunspot about the size of the Earth, diameter of the Earth. And the top sunspots have been marching their way across for several days now. It's interesting that clouds provide additional filtering and sharpen what we are looking at. Yeah, this was not visible up here until the clouds moved through those two sunspots. And the upper two also. I have to do my homework and find out what kind of filtering clouds perform. Because when the clouds go through, uh, we're seeing things on the sun that were not visible without any cloud. So April 2024, just under 2 years away, is the total solar eclipse visible in North America, and we're going to be prepared to cover it live. I believe I have the right equipment at this point, the right setup to cover a solar eclipse, so looking forward to it. Except, of course, for the 60% probability of clouds on that day. And given that the setup is very portable, I foresee traveling, if I must, by a few tens of miles, maybe 100 miles in either direction, or in any direction to cover it. So there is a reasonably active sun today. With a very large sunspot, a few tiny ones next to it, another cluster at 5 o'clock, and a cluster up in the top tier that I've been following for a week now as it makes its journey from right to left. The view that you're seeing right now is actually through clouds. We have thin clouds outside. And I am particularly perplexed by the additional filtering that the clouds give us, because I'm seeing sunspots that were not visible when the sky was totally clear. The big sunspot at around, well, in the middle of the sun, was not there 2 days ago. It appeared yesterday. And those tiny ones have joined it since then. Not sure what this is, other than it's really big. That is a closer view. I estimate that it has the diameter of the Earth. It's about the size of the Earth. Earth would fit in that hole, big hole. Unusual activity on the surface and very, very little, if any, activity on the edges of the disk. Sunspots are caused by electromagnetic fields, and they usually occur in pairs. Field coming out of the sun and then re-entering somewhere else. So we're looking at three distinct clusters of activity today. The one in the top tier, and then two in the bottom tier of the sun, or bottom half. But certainly the large sunspot at around 4 o'clock is the one that's of quite a bit of interest. I'm going to zoom in on it and see if I can improve the focus, because it looks like it has some hairy legs sticking out of it. Focus on my Lunt 50 is manual, unlike the nighttime telescopes. My Celestron has a remote focuser and Stellina has an autofocuser. This one is manual, so hang in there as I make my way to the telescope. Yep, this is the best we're going to get. Not talking about the clouds, but the forecast is for a cloudy day. Okay, folks, thank you for joining me this morning. Looking out of the window, there's a very large cloud that has just covered the sun, and we're unlikely to be coming out of it anytime soon. So long from the Rooster Inn.